This is Sound Noise Acoustics Engineering Podcast, episode number 9, brought to you by Sound Solutions, an independent acoustical consulting firm. They're found at ssacoustical.com. This podcast provides you with knowledge and resources to address acoustical issues. I'm Bill Holliday. Thank you for joining me. On this episode, I'm going to be speaking about barriers, giving you some tips, 9 tips to construct or have a better sound barrier. So noise walls, sound barriers, acoustic fences, noise walls, they are a very important tool in reducing noise in environmental acoustics. You really only have 3 choices for attenuating noise. You can treat the noise at the source, that's probably the best and most efficient. Treat the path or treat the receiver. So treating the source, if it's an industrial source, a machine, a generator, a car, treating the source would mean replacing it with a newer one. In the road situation, sometimes they use rubberized asphalt concrete that reduces the noise of the wheel-road interaction. If it's an industrial source, it could be putting mufflers, attenuating, identifying what the source is and then addressing that. Sometimes you don't have control of that, or there's limits to what you can do. Treating the receiver means, if it's a residential receiver, it could mean improving windows, improving walls. In industrial settings, it could mean wearing earplugs or headsets, head protection. The other option is treating the path, and this is very commonly used, and that means putting some kind of wall or obstruction between the source and the receiver. So let me get to these 9 tips. Number 1, the barrier needs to block the line of sight, or that acoustical path, between the noise source and the receiver. So between that, what's generating the noise and your ears. If you don't block that line of sight, you're not attenuating. You're not reducing the noise with any kind of barrier because it's not obstructing and forcing the noise to diffract over. A rule of thumb is that if you block that line of sight, just block the line of sight, you get about a 5 dB noise reduction. And that brings us to number 2. The higher the barrier is, the more attenuation you achieve. The rule of thumb is for every foot that the barrier breaks the line of sight between the source and receiver, about a 0.5 decibel noise attenuation can be expected. Now, the actual attenuation is going to depend on the spectrum of the noise. High-frequency noises are attenuated easier than low-frequency with barriers. Low-frequency noise diffracts over a barrier easier. So depending on what the spectrum is, and the other factor is the distance between the barrier and the noise source and the barrier and the receiver. And that brings us to number 3. A barrier is most effective close to the noise source or the receiver. So throwing a barrier midway between the source and receiver is the least effective thing you can do. The best is putting it as close to the road or the noise source as possible, or as close to the receiver, the home or the person or the receiver as possible. Number 4, they should be constructed, the barriers, the sound walls, should be constructed airtight, no leaks, not at the bottom, not between individual pieces. You shouldn't, if it's road noise, you shouldn't have a gap for a driveway, or if you do have a gap for a driveway, you've negated the effect of that barrier. You've just about made it not very useful at all. Openings work with sound. It works a lot like light. If you can see light through it, you're going to have some problems, or it's going to be the effectiveness is greatly reduced. You want it to be airtight and solid. The other one is the barrier should be solid. So around 2 pounds per square foot. It really depends on how much noise attenuation you're hoping to achieve. Like I was saying, let's say you want to achieve 7 dB of noise reduction. We're saying the barrier has to break the line of sight by about 4 feet. That'll give you 5 dB for breaking the line of sight, plus another 2 for the 4 feet of additional breaking the line of sight or above the line of sight. If your goal is 7 dB, the noise going through the barrier, if you can reduce that by 17 dB, you're in good shape. Then the noise going through the barrier is really negligent. It's not contributing much at all to the overall noise heard at the receiver. So let me say that again. If you're just trying to get some attenuation, let's say 5 dB, you don't need to have a 12-inch thick concrete solid wall. You're wasting your effort because all the noise, the majority, 99% of the noise, is going over the top of that barrier. And so making it super solid and so nothing goes through it is wasting your effort. But saying that too, you need a solid barrier. It should have some heft to it. Vegetation is not very effective at all. To have effective vegetation, it needs to be dense and at least 50 feet thick to get some significant attenuation. Otherwise, it's decorative. It can be psychologically effective. If you don't see the road, maybe it doesn't bother you. But as far as reducing noise levels, the low frequency noise especially will go through those openings in vegetation. So you want solid barrier. Mostly the consideration with barriers is other than just the heft. I mean, you can get a wood barrier that's solid, but there's other factors that might discourage you from getting a barrier like that, like weather, like vandalism or treating. So let's go back. Now we're on number 6. The number 6 issue for having a good sound wall is that in many cases, to be effective, the side of the sound wall facing the source, the noise source, should be absorptive, acoustically absorptive. So a lot of times you'll get, if you have a solid reflective wall, you can get reflections off that wall, and that can amplify the noise to the other direction. The other issue is, let's say you have a train going by a barrier. That train will have the direct, or the first path will be from the wheel-rail interaction to the top of the barrier, but then there'll be a reflected path when you have these 2 parallel surfaces, the side of the train and the wall, and you'll start getting multiple paths, multiply reflected paths, adding to the noise level at the top of the barrier, which gets diffracted over the top. So putting absorption on that inner surface or on the surface facing the noise source, one, will help the effectiveness of the barrier in many cases, and 2, it'll help noise from being reflected to the other side of the noise source, to the side without a barrier. And if you have 2 parallel barriers, even more reason to have some absorptive treatment, because then you can get some multiple reflections, which will reduce the effectiveness of your barrier. Number 7, selecting the material. So there's a bunch of considerations to getting a barrier up there. One is the cost, durability, washability, weight, wind load, what kind of anchors, what kind of supports you need, space available. And that ties into number 8. Earthen berms alone or in conjunction with a wall can be used. The real factor we're looking at is by how much is that line of sight broken? By how many feet is that broken? So if it's an earthen berm, fabulous. If it's a wood wall that's solid, no gaps, fabulous. If it's a concrete wall, great. They're all going to give you very comparable reductions. The advantage of a berm could be that noise isn't getting reflected back to the noise source or back to the other side. So that could be advantageous. It also could be helpful, or it could be useful, because at a construction site or at some locations, a berm might be easy to construct if you're removing dirt, and you can just easily stack it up and provide mitigation that way. The disadvantage is it's going to be wide and take up a lot of space. That goes into number 9, what barrier materials could be. What are some examples of barrier materials? And I was just thinking of something here. Weight, washability, space available. I lost it. Okay. Materials. You can use pour in place or precast concrete panels. You see those a lot for highway applications. CMU concrete block walls. That's fine. Tongue and groove or board and batten. Wood walls where there's no gaps. They're being sealed. You're either having a fit where there's no seam between the two boards, between the different boards, or there's an overlaying piece of wood that covers the gaps. That works. I mean, the disadvantage of wood is, of course, weathering. If it's out in the sun, it could warp, it could expand and contract, and it might need to get replaced much more often than a CMU or some concrete wall. There are cement-based wood panels or panels that you could use. Prefabricated metal panels are a common noise barrier material. So they sell these barriers. They're pretty thick, a high or a low gauge, a thick gauge metal acting as a barrier, fiberglass or some acoustically absorptive material, and then perforated metal on the side facing the noise source. They need an independent, they drive in some posts, usually these metal like I-beams that you put these panels in, and the panels are usually only a foot or two high and then 8, 10, 12 feet wide so that they're manageable to place into those support beams. There are also PVC barriers, which are really similar to the metal. They're just lighter in weight. They're very effective. They provide sufficient, for most applications, provide sufficient attenuation, and they do that absorption. They do provide absorption. Loaded vinyl can be used. Loaded vinyl is just a heavy, flexible vinyl sheet that they sell. You can have it quilted with absorption on both sides, on one side or not at all, depending on your application. The advantage is it's movable. You can hang it from a metal frame. You can open it to get in and out. They seam, or they put these different pieces together, usually with Velcro, which makes it really easy to use. If it's outdoors, it can weather. It's not going to last as long as a concrete wall, of course, but it has its advantages. It's not as heavy, can be moved. For portable noise sources, there are portable barriers for a jackhammer, for example, that's not a permanent noise source. In acoustic blocks, cement blocks, they do sell them with absorption on the inside, and they have slats, openings, so that they do absorb the noise that's hitting them and not just reflected. So noise hitting a surface is either reflected, absorbed, or transmitted through. And so the idea of absorbing is so it doesn't increase the noise level or cause a problem on the other side. All right. That is all I have for barriers. Those are the 9 issues to make them better. It needs to block the line of sight. The higher the better. Closer to the source or the receiver, the better. It needs to be airtight. Acoustical absorption in many cases is necessary, and that can be provided with the barrier with fiberglass, or it can be added on after the fact. There's trowel-on materials that can be applied to give you absorption after the fact. Barrier needs to be solid, heavy, not just a little row of trees or shrubs or vegetation. There's many factors to consider, not just how much noise it'll reduce it. You have cost, weight, zoning requirements. Earth and berms are an option, and I've provided some material options. Our ebook on our website will give you some places where you can get those different types of barriers that I discussed. All right, that wraps up episode number 9. The next podcast, I'm going to be talking about 10 issues or 10 tips for improving the sound transmission or sound isolation between rooms. Improve that sound transmission class of a wall. All right, thank you for listening to Sound Noise Acoustics Engineering Podcast. I'm Bill Holliday with Sound Solutions, independent acoustical consultants at ssacoustical.com. As always, I appreciate your feedback. Please leave a comment. Contact me on Facebook, Twitter. You can email me, bill@ssacoustical.com, or feel free to call 520-979-2213. Take care.